So it should make sense that those are the same. Just the sine and cosine are switched on this. Okay, what about this? What about the coordinates at this point right here? What are the coordinates for this? Now, it's the x-coordinates first, which is a radius of 1, and the y-coordinate, 0. So what do you think the sine of 0 degrees is? The sine is the y-coordinate. So the sine of 0 is 0. What's the sine of 360 degrees? 0. What's the sine, or what's the cosine of 0 degrees? 1. So you can use that as well. Well, what's this up here? So at 90 degrees, what's the cosine value? No, now, well, so on this one, when you look, the cosine is the x-coordinate, which is 0. Okay, so the cosine of 90 degrees is 0, and what's the sine of 90 degrees? 1. Okay, so when you look at these, let's find this one last angle measure, and that's a 45-degree angle. So in a 45-degree triangle, we're looking at the following pattern: x, x, x root 2. Again, if you recall that from geometry. Okay, so here when we take our sine, so here's our 45 degrees, or our cosine. Our cosine is adjacent x over our hypotenuse x root 2. So you wind up with 1 over root 2, and if you simplify that and rationalize it, it's root 2 over 2. Remember, you just move the radical up and divide by the number in the radical. And then our sine value is opposite x over hypotenuse x root 2. So what's that going to be? Same thing, right? 1 over root 2, which is equivalent to root 2 over 2. And so with just this set of answers, you can find the sine, cosine, and tangent values, which in turn leads to the other 3 reciprocal trig functions for all of the angles, multiples of 30 and multiples of 45. Okay. Let's talk about how this is the case. Okay. First is, we talked about reference angles last class as well, correct? Right. When you're looking at a reference angle, the reference angle is the angle, the central angle that's formed when you create an angle and you connect it to, the x-axis. So if we're looking at this angle right here of 120 degrees, so here's 120. So here's where that ends. Well, if we take a look at the angle formed by that terminal side and then the x-axis in the same quadrant, what is this angle, this reference angle, going to be? Remember our reference angle, which is theta prime, is equal to, so we have this full rotation of 180. We move back to where 120 is. How many degrees did we move back here? 60. So our reference angle is 60 right here, right? Okay, so what is the cosine value? What is the x-coordinate at 60 degrees? 1/2. So that means that in this reference triangle, this distance, this x-coordinate here is going to be 1/2 as well, but it's in the which direction? To the negative. So our x-coordinate right here is going to be negative 1/2. And when we look at this angle right here, what's the sine of 60 degrees? Root 3 over 2. And so when we move it over here, we get root 3 over 2. And is it positive or negative? Now look at it. It's positive, right? So they have the same y-coordinate. They have opposite x-coordinates. So what do you think the coordinates at 135 degrees is going to be, this measure right here? So the x-coordinate is going to be negative root 2 over 2, and the y-coordinate is going to be root 2 over 2. Good. And what about this angle, 150 degrees? Okay, so the x-coordinate is going to be the opposite, negative root 3 over 2, and the y-coordinate is 1/2. Okay, what is the coordinate going to be at 180 degrees? Negative 1 and 0. Okay, so if you looked at this and I asked you just quickly, tell me what is the sine of 135 degrees, what would the answer be? Root 2 over 2. What if I asked you what's the cosine of 150 degrees? You look at the 150, the cosine is the x-coordinate, negative root 3 over 2. Okay, so this is what's called, this is the unit circle. This is what it's used for. If you guys take a math class that involves the pre-calculus or trig stuff next year, you guys will have to do this, and they'll probably start it relatively early. You do need to be able to identify all of the trig ratios at any of these given angles. So again, any multiple of 30 or any multiple of 45. Okay, so what do you think is going to happen when I come down to this quadrant 3? Okay, so here is 210 degrees. So now we know that it's going to be a negative x and a negative y coordinate. Okay, so when we look at this, our x coordinate is going to be negative what? Which x does this map onto? No. So the x coordinate is negative root 3 over 2. The y coordinate is negative 1/2. Again, if you had to identify the reference angle for this, the reference angle is the angle formed by the terminal side and then the x coordinate in that quadrant or lining that quadrant. So this angle right here, it's an additional rotation of how many degrees from 180? 30. So the reference angle here is 30 degrees, which means these coordinates should map onto the same things as 30 degrees. Does it? Root 3 over 2 is the cosine, 1/2 is the sine, but now it's in the negative direction. Okay, and so what you can do, I want you to see if you can fill in the remaining coordinates for each of these points. Let's just stick in this third quadrant. So find the 215 or the 225 and the 240. So what are the coordinates at 225? Negative root 2 over 2 and negative root 2 over 2. And at 240, again, it maps directly onto this one that's straight above it, a negative 1/2 and a root 3 over 2, but in the negative direction. Okay, at 270, what are the coordinates? 0, negative 1. Now when we move into quadrant 4, so here our x is positive, our y is negative. So when we look at this, we can map directly up here to our reference angle of 60 degrees. 1/2 and root 3 over 2 in the negative direction. 315, root 2 over 2, and then root 2 over 2 in the negative direction. And then 330, root 3 over 2, and then 1/2 in the negative direction. And again, back to 360, it's 1 and 0 again. And then this whole thing cycles back. Okay? So here's what you're going to be asked to do. Okay, one, you know how you guys did the unit circle test with just the angles? Now you're going to have to do it with these coordinates. But again, how many coordinates did you have to memorize? You had to memorize 2 pair, right? Which pair of coordinates will you have to memorize? And even then, you can recreate them using these 2 diagrams. But if you can memorize 2 pair, the 30 degrees and the 45 degrees, you can answer every other problem in this, correct? So if you have the 30-degree one, all you need to do for the 60 degrees is switch them up, a 1/2 and then a root 3 over 2. And then after you find that, you should be able to find these, the coordinates at these 0, 90, 180, and 270 pretty easily, right? It's just, if you can plot a point on a graph, you can find those. Okay, and then all you need to do is find the pieces that are opposite them. So here, using the reference angle of 60 degrees, we have a negative 1/2 and a positive root 3 over 2. Using that same reference angle of 60 degrees down here, we have a negative 1/2 and negative 3 root 2 down here. Tangent. And so the tangent is equal to sine over cosine. Okay, and so if I asked you to find what is the tangent of 180 degrees? Of 180 degrees, what would the tangent be? 0 over negative 1, which is 0. What would be the tangent of 45 degrees? it's a number over itself. So 1. Okay, what if I did something where I said or asked you for the tangent of 60 degrees? So the tangent is root 3 over 2 divided by 1/2. Well, dividing by a fraction is equivalent to multiplying by its reciprocal. So if you thought of that as times 2 over 1, 2's cancel. So what is the actual tangent of 60 degrees?